Okay.
Start with prayer.
Yeah. I could say it.
Okay.
All right. Dear Heavenly Father, we're so grateful to gather together and to discuss our classwork, and we're grateful for this opportunity to continue our education and to do so in such a spiritual environment. We ask for the Spirit to be with us and to help us as we take this quiz and as we look to finish out this semester. We're grateful for Thee and for Thy Son Jesus Christ and for this Christmas season, and please help us to always remember Him. And we say these things in His name, Jesus Christ. Amen.
Amen. Okay.
Okay, so does everyone have the quiz up?
Yep.
Almost. Yep.
Okay. All right, so
We're good. Go ahead.
So what do we got for the first one? Let's see. Looking for what the alternative
be-
hypothesis?
The null is equal to 0, and the alternative is not equal to 0.
Okay. I was
It'll
starting to
always
second guess myself because this is like a new lesson. So I was like, oh, maybe there's something different that I missed.
And so it's always going to be not equal, right?
The alternative's not equal. The null is equal always.
No, right.
And the alternative is not equal. Computer's really hot. Sorry.
And number 4 is the third option. I'm pretty sure.
Yeah.
Yep. So number 5, a plot of residuals supports using linear regression when look normally distributed, the residuals are all positive, you see a megaphone shape in the residuals, you see a pattern in the residuals. None of those is true. Because when you make the scatter plot, you don't want it to be normal. You want it to be all scattered. And if you see a pattern, then it's not going to be. Am I wrong?
I might go back through the lesson to look.
Right.
One of the subheadings is residual plots.
Right. It says if there's a pattern in the residuals, it suggests that linear regression is not appropriate.
So I don't think the residuals all have to be positive, do they? Because in one of the data things we did, the residuals were negative.
Right. Well, and in the example for the crocodiles, half are negative and half are positive, pretty much.
And then it talks about like a megaphone shape actually shows. I was reading that part just before you guys got on, and it says that when it has a megaphone shape, it suggests the variance of the error terms is not constant for all values of x. So then you can't use a linear regression because the variance needs to be constant. So I'm
Would it
not
be the
seeing.
residuals? Would it be the residuals are all positive then?
Because they weren't all positive.
Oh.
Like in the data files that we used.
All right, using.
I don't know. That one's baffling me.
So I found the part in the lesson where it says there is no obvious pattern in the data. If linear regression is appropriate, then the residual plot will show no patterns and will consist of a random scatter. And then it talks about, let's see, if there is a pattern in the residuals, it suggests that linear regression is not appropriate. And then it gives the specific patterns that could appear in a residual plot. So the megaphone thing is clearly not the answer. The outliers. Wait, there we go. There's my tab. Let's see. Let's see. Oh boy.
It should say something like they look all random or they're scattered all over the place, shouldn't it?
That's
Or
Right.
am I
kind of,
missing?
No
yeah.
pattern and will consist of random scatter. So I think the obvious one that is definitely out of it is that you will see a pattern, right? I think that's
We could all choose something different and see which one gets it right.
okay. I'll choose the
Yeah.
megaphone.
I'll choose
I'll
the
do
Wait, which one did you say you broke up?
I'll do the first one.
Okay. Then I'll do the second one.
Okay.
So we didn't do the last one, right?
Correct, yeah. I've got a feeling it's the first one somehow. It's either the
I don't
first or the second one. So I think it's between you and me, Christine.
know. This should be interesting.
We'll see.
It's one way to try to figure out, huh?
Yep.
All right, so now we need the data from the math self-efficacy study. We need the data for that.
Yep.
It tells us which one to put, so it's not this.
Right. It might not be the same as last time.
That's what I was thinking, and tell me if I did it right, because I already put it in. But like it seems like you don't just copy the columns in the order they are. It's yeah. What am I saying? Whoops. That's not what I heard. Oh my goodness, my computer's not letting me go back to Excel. There we go. So you put the score in the second column for the inference data thing, right? Is that what it's telling us to do?
Score as the response variable, and then confidence as the explanatory.
Okay. I've got them all in.
Okay.
Are we ready?
Yeah. So for number 6.
So the program already computes it for us, right? It's already there in the columns D and E, right? So E is the residuals.
In the lesson, I was reading something about making a. Let's see, what was it saying? Making a residual plot. Is that what we have to do?
That's one of the things we do with it. The other thing is, so you make a scatter plot, and the way you do that is select all the residual numbers, and then you click Insert, and then over by charts, yellow and blue dots, it looks like to me. Kind of in the middle of all those graph things. And that's a scatter plot.
Oh, I see it. Okay.
So you
And we
can
just want the
create
first
that.
option, it looks like.
Yep. So you create that, and it just shows kind of randomness, right? But then the other thing you have to do with it is the QQ plot, which is in that other file, the descriptive statistics.
I would.
So when I did the
I
Q
would
plot.
say that. Yeah.
So when I did the QQ plot, because you have to sort them lowest to highest, the lowest number is negative 38 point something, and the highest number is 23.4. And the QQ plot shows the linear, it's all straight. So, but I'm not sure if that's the way we're supposed to answer this question. Does that make sense? I wasn't sure.
Yeah.
I kind of went on to the next couple questions, and when it told me to do the QQ plot, question 7, that's where it says that. Then I was like, oh, wait, that puts them in that range. So,
Yeah. Where did you say you saw negative 38 as like the lowest?
so in the descriptive statistics Excel sheet, that's a different file that we used, and
Oh,
it does the QQ plot histograms.
so are you thinking the answer is the first one? The residuals are between about negative 40 and 25?
That's my guess. I'm just not positive because I don't really know what it's asking.
Because I know it's not the third one because all the residuals are not negative.
Correct.
They're mixed.
And the residuals form a linear pattern when you do the QQ plot, so it could be either one of those.
Oh boy.
Yeah, but if you do the scatter plot, they don't form a linear thing, which I'm not sure. So I think it's the first one, I guess. I just didn't,
Yes.
I kind of stumbled upon the answer, I guess, is what I'm saying. I don't know
Yeah, yeah.
for sure.
And then number 7 says, based on the QQ plot for these residuals, what can we say about these residuals? Residuals are not clearly normal. Oh, excuse me. The residuals are fairly normal. The residuals look right skewed.
So it forms a straight diagonal line on the QQ plot. So we'd say they're normal, right?
You kind of broke up.
Sorry. On the QQ plot, they form a diagonal line, and it's all together, on the line. It looks like a line, so I'd say they're fairly normal.
Mm-hmm. Yep, that's what makes sense.
Are you with us, Taylor?
Yeah, sorry. My Excel was really slow, so I'm just kind of inputting it just now.
No.
So, let's see, I guess my question is, um, so we're putting it into the descriptive file, and
So
then,
we take the residual numbers
oh, okay, now I gotcha.
and we make a Q. So in the quantitative inferences, just select those numbers and you can
Right,
create a scatter plot. And that one is pretty random.
right,
Looks kind of spread out all over to me. And then I took those same residual numbers and I put them in the statistics one and created a QQ plot. So then when you paste them, then you have to sort them smallest to largest.
right,
And that's where I saw that the numbers fell into that negative 40, 25 range.
okay, sweet.
And then looking at the graph, they look like they're going in a linear pattern. So then question 8 says, use software to create a scatter plot of the data. Given the scatter plot, residuals plot, and the QQ plot, I thought the scatter plot was the residual plot. Are those two different things? Am I missing something?
Yeah, the residual plot is a different thing. That's what I was saying.
What's a residual plot?
It's where you copy columns. Let me open this quick. It's where you copy columns D and E, and then I want to say you make a scatter plot off of columns D and E.
So that's the scatter plot, though. Isn't that the same thing?
It's a great question. I
No.
mean, in the lesson it calls it a residual plot.
Right. So you have the scatter plot, and then you make a residual plot, and then to test that, you put it in a QQ.
What's the scatter plot?
The scatter plot is the relationship between X and Y. So it would be, let's see, it would be columns A and B.
So we
I
create
think that's
two
what.
different scatter plots?
That's what I'm kind of getting.
Yeah.
Okay. Let's know. So did you make a scatter plot? I did not make the scatter plot.
So mine turned out really funky. I don't really know how to do it because I'm following the instructions.
So, okay, so they're both scatter plots, right? But one's of the residuals and one's of the X and Y together. Is that right?
Yeah. Like correct.
Okay.
They both are scatter plots.
And the residuals we want to be all random. And then the scatter plot of X and Y, we want it to be hot dog shape. Right?
Correct. Yeah.
Okay. So I'm just created. Okay, so my scatter plot of the XY looks, it's at a diagonal, but it's still kind of compact hot dog type shape. It'd be kind of a fat hot dog, but there's a couple that are kind of outlined, but
And so we're trying to see no pattern, right?
for the scatter plot of X and Y, we want it to look like a hot dog.
Right. Okay.
And then the residual, we want it to be really random and not any kind of pattern.
No, right. Yeah.
Okay. So now back to the question now that I got in my head right. So now we're going to say we look at these three different things to do the 5 assumptions, right? So if there's a linear relationship between X and Y, that's the scatter plot of X and Y, and that's a hot dog shape. So that's correct. That's there, right? Did you follow that?
Yeah.
Okay. The error terms is constant for all values of X. I think that's one we can't check. No, that's the residual plot. As long as it's not a megaphone, then that's good. They're constant if it's not a megaphone shape. So that's good, right? It's not a megaphone.
Mm-hmm.
Okay, then the residuals are normally distributed. That would be no pattern in the residuals.
Mm-mm.
I don't know, or is that not one of them? So wait, that may answer the question we were kind of, where we each picked a different one. So if we see no pattern in the residuals, then that tells us the residuals are normally distributed.
Yeah.
So that means that's what the answer is for that question.
I told you were right.
No, we're on 8 now. It was back 5 or 6,
Yep, it's
right?
I think it's number 5.
So the residuals look normally. So that's what that means. I need to write a note because I'm going to get mixed up on like wording and stuff. So if there's no pattern, that tells us the residuals are normally distributed. Is that what you guys are seeing there, or am I understanding
Yep.
that correctly?
Yep. I'm actually writing that down right now too. So if there's no pattern of residuals, we can assume that they are they should look normally distributed.
Well, I think seeing the randomness of them in the scatter plot of the residuals tells us they're normally distributed because it is so random. It's meant to be random.
Oh,
I
okay.
don't know.
That makes sense, yeah. So it's saying that they're doing what they should be doing.
Okay, so I'm back down to 8. The x values are measured without error. We can't actually check that one. But that one's, I
Yeah,
guess,
that's
when we
true.
always there's a
What do
I don't
we?
know if it was in the textbook or the video that went with the lesson where he gave kind of a little chart for these 5 things. And that's what I have written in my notes. Is the last 2, x are known constants,
Uh-huh.
and the observations are independent. It says we can't check those directly, but they should be because we should have measured the x's correctly and without error in our study, I guess. But do we check those? Because they're not satisfied by the data, correct? I don't know. They're part of the 5 things that we need to check. Just not sure the data says that that's what they are.
So what did we end up getting for 6 and 7?
For 6, we got the residuals are between -40 and 25.
Okay.
7, we got the residuals are fairly normal.
Sweet. Okay.
The question I have is, do we check all the boxes here? Or do we just check the ones that we know because of our data?
Hmm.
I think I think because it says, given this data, which ones can we check. I don't know. It's one of those that it could kind of be either or. They're going to say, we know those two because we just assume the data.
Yeah, I see what you're saying. Is it asking just based on what information we do have, or? Oh man.
Well, we can try it one way, and then if it wasn't right, I'd say check them all the next time.
Yeah.
Sound good?
Yeah. Which ones did we end up checking?
First three.
Okay.
All right. Question
Number 9.
9.
What is B1, the estimate for the slope? Round to 3 decimal places. Oops. B1.
You're getting 12.695.
That is what I got.
Right now, construct a 95% confidence.
12.695?
Yeah, so in the table where it says slope B1, and then the number right next to that under B. So it's the kind of the table that says model, and then it has y-intercept B0,
Oh, yeah?
slope B1. Then the 12.695 is the slope for B1. Ready, go on?
Yeah.
Huh.
Okay. Construct a 95% confidence interval and input the lower bound and upper bound.
So we should still be at the 95%, right? Like we never.
Yeah, that's what we didn't change anything.
So 10.674 and 14.715.
Yep, because we do everything for the slope. Is
Right.
something I read. So we're kind of, I don't know what we use the y-intercept, confidence interval ever for, but it said we're always looking at the slope. So it's why we're using all those bottom numbers. Excuse me.
All right. Based on the evidence and using level of significance alpha equals 0.05, what decision would you make regarding the hypothesis test for beta sub 1? Fail to reject the null hypothesis test because the correlation coefficient R is less than 0.95. One sec.
So our p-value is what?
Oh, right. Yeah. And what is our P?
It'd be next to the slope, right?
Yeah.
That's the one we're looking at. And so it's,
0.00000.
yeah, 24 zeros.
Yeah.
So
So it reject the null because T equals 12.476. Reject the null because P is less than A. Fail to reject because P is greater than A. So it should be P is less than A, so we're going to reject. Right?
yep.
Just like normal.
Mm-hmm.
Yep.
Sweet.
Okay, so 13 says for a hypothesis test of B1 slope, if you reject the null hypothesis, what does this mean? So it's either the third or the fourth, I mean the second or the fourth one.
Because we reject, so we have sufficient, right?
Mm-hmm.
And then we're talking about the slope always. So it's basically, it's sufficient
And then not
slope.
zero.
And then the alternative hypothesis, which was not equal to 0.
Sweet.
Yep.
Good. All right. Now we're using the estuarine crocodile information. Question 14 says, so we're using the head length was used to predict the body length. For this data, which variable is the dependent variable? The body length would be because it's dependent on the head. Head to determine which is. Right?
Yeah.
Maybe. All right, so now we got to input the data and do a 95%. Dad pick Alyssa up from school? Yep. You been at the bus stop? I'm so sorry, sweetheart. She had a doctor's appointment. I love you. Thanks for taking care of your sister. Yeah, I'm still in class. Love you. Oh, goodness, you're close. Love you, dear.
Well, did we say head length?
Yeah.
For
Okay, that's what I thought. That's what made sense.
wait, what?
For number 14, did we decide on head length?
Oh wait.
No, body.
Wait. Oh yeah. No, I'm sorry. Sorry. Yeah.
Oh,
Dependent
okay.
is response. So yeah.
Okay.
My bad. I need to make a note of that.
All right, so we can just copy both columns because they're in the right order. I'm copying still.
There we go.
Copy.
Oh, Excel can be really slow. There we Okay. Okay. Let's see here. Is the margin of error 10.801?
I don't know. I don't remember anything talking about the. Or is the margin of error the difference between the lower bound and the upper bound divided by 2?
Oh yeah.
Oh, okay.
Would that be right?
For B1, yep.
So lower bound is 7.218. Upper bound 8.103. Is that what you got?
Yep. So 8.103 minus 7.218, and then divide by 2?
Yeah.
Okay. Oh, whoops. Uh, 0.4425.
So 0.443.
Yep.
I'm good with that. Give it a whirl.
Wait, I'm not getting that.
Uh-oh, what'd you get?
I'm like way off. So wait, so we're doing lower minus upper divided by 2?
What'd you get for your lower?
Negative 0.830?
I got 7.218. Did you delete all your data from the previous?
Yeah, let me check if I did X and Y right.
We should have 30, no, less than 30. There's something that tells us on here how many are N is, just to make sure we got the, there's not like an N on here, is there?
Ooh.
So my first X is a 24, and the Y that corresponds is 161.
Yeah.
You got that? And then my last one appears in 31A as 51,
Yep.
and B is 368. And then our confidence interval is the slope. Did you do the y-intercept confidence interval?
Oh, okay, no. I didn't even do that. I did I was looking at prediction interval for Y.
Oh, okay. Yep.
Okay, hold on. Sorry.
Oh,
No
you're
No
wonder I'm
fine.
problem.
so off. Okay.
It helps though, because then it makes us all stop and think, wait, what are we doing? And we double check ourselves. So it's actually good when one of us
Yeah.
says, whoa, and wait, I didn't get that.
So negative 0.442?
I got positive because it's 8.103 minus 7.218.
Oh, so
And
okay,
then divide by 2.
okay. I think I did lower minus upper. All right. All right, gonna get there. Okay. Yep. Positive. Sounds good.
Okay, now input the lower bound and the upper bound. Oh, I hate interpreting confidence intervals. I screw it up every time.
Same.
It's like every question I've ever missed on a test has to do with confidence intervals. I don't know why I can't get it in my head.
I want to say it's the first one.
I think it's the first one. I don't think it's ever a chance. Like the word chance, I don't
Yeah.
think it's.
Yeah, it's never that.
And
I mean,
then
that data can't even provide what, you know,
To reject or
right.
Yeah.
cool.
I may have a quick question though before we submit.
Yep.
So what did y'all get for questions 10 and 11? Because I have a feeling that my data was different than your data.
10. For 10, I got 10.674,
And what about 11?
14.715.
Yes, there must have been something wrong with my data because I had like 0.048 or something and 0.035 for number 10. So something was definitely wrong with the data I inputted. I wonder what it was.
So yeah,
Or
I just
possibly,
submitted and I just got them all. We're all good.
oh,
Okay.
cool.
So I think
So could you tell me 10 and 11 again? So 10 was 10 point something. I remember that.
Okay, hang on. Just gotta scroll back up.
Okay.
Well, maybe not. What did my computer do?
Uh-oh.
Like all the question parts left me. Hang on. What are you doing?
It's having a brain freeze or something.
It did. It's like you can see. I can see the little thing on the side where it says this, which questions are saved, but then where the questions are is blank. It was like,
Interesting.
what numbers did you
okay,
get,
here.
Micah?
Number 10 and 11.
So 10 is 10.674
Okay.
and 11 is 14.715.
14.715. Okay. I'm wondering if my data was just wrong because we were just using the same lower and upper bound, the same column or the same, yeah, as like
It's always
the
the
lit problems.
slopes.
Yeah. So
Always
I
look at
guess
the slope data.
okay. I'm guessing it
All
was just
right.
my data or something, but cool.
Thursday, might you guys be able to meet a little bit later?
I should be able to. Depends. I guess it depends what time.
Yeah,
Um,
I'm good. I'm good. I just have a class at 3:15. So
and this is 12:30 for you guys. Is that right? So it's 2:30. Uh, Actually, you know what? Keep the time because I'll be at a church building. My daughter has an appointment again, and my husband's out of town. But I'll be at the church building, so I'll have internet. I just may have to check out early from our class. So just
oh,
keep it the same, and I'll catch the first part with you guys, and then um, if I need to check out, I will, but I'll get part of it with you at least.
for sure. Yeah.
And then for our project,
Yeah, I
did
believe it's
our
my turn.
did
What's the
our
next part of it we're doing?
we're doing the make an inference or whatever and
And
take
take
action.
action. And I think I'm in charge of both of those.
If there's any part of it you want us to do for you or work on, I'm happy to help.
Okay.
Um,
I
and
I just might need help figuring out like what the statements should be and whatnot, and uh, I'm not sure.
Right.
okay.
I took a little gander over it this morning over the instructions, and it just looks like it's
I didn't look this week. I looked, before I kind of looked over it, but I didn't look this week. So I'll take a look too, and then see what else I can do to help. I don't have any other classes. It's the only one I'm taking, so
okay.
if
So
I
I
can help,
appreciate it.
I'm happy to do it.
so I feel like I kind of just um I mean, I'm not even sure what we really found out because
I
like
know
Well,
that's what I have to say.
there was a difference and like that one that one picture that I found on the home run tracker where it like showed like you could put like another layer of any other stadium and you could clearly see that like those home runs wouldn't have made it over the fence in our smaller field. So like
Well,
That was
it goes back to our hypothesis,
right.
and that's all we got to write about is do we reject the hypothesis or do we not reject it? And so if it does, then what does that mean?
I think my question is like, our hypothesis, like our alternate, we played it safe and we just said not equal, and it isn't, or like it still is not equal, but is there, like, how do we determine kind of like margin of error or something? Because how do we know whether it's large enough to, you know,
Well, we did 30,
reject
so
or
it's
whatever?
large enough to determine. Are you saying what is our conclusion? What are we going to recommend be done?
No, no, no. Like what is our p value and what is our alpha so that we can have sufficient evidence to reject or whatever.
Well, we had to set that before we started the whole data collection. So we're doing a 95%. So if
Uh-huh.
our p-value is less than 0.05, then we reject, right? Because we
Yeah.
have to determine that before you actually do the study. Before you collect data, you have to determine your confidence interval or your margin of error or whatever it is called, and
Right.
not your
Right.
margin of error, but
No, 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 right, right. Otherwise it's like, oh, yeah, 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 yeah. We're good.
I'll make it fit to whatever I want my data to say.
No, exactly. So yeah, I think if we just find our p value, which should just be plugging it into a certain one of the Excel docs, then we can, I think that might be able to help you out too, Micah.
Okay.
Well, because
I
we
don't,
talked about which test we were doing, and it's a independent sample one, isn't it?
Yeah, that's what I remember
The
talking about. Yeah.
dependent. So
Um,
we need to show that. Um, so I think in this part we show our statistical stuff. So we're going to show the one sample t-test. No, it's two sample t-test, independent variables, right?
yeah. Yeah.
And so we're going to take our numbers and put them into the two sample t-test, which is what we have on there. And then that gives us our p-value
P-value.
sweet. Okay, no, yeah.
and all of that. So all we have to do is, I already copied my data into one variable column on that in the data thing. So we just need to copy Micah's in everything for us.
Sweet. And I read the example on the math homepage, and it was saying that, like, for taking action, we could like write a letter to the leaders of, Major League Baseball or something, and say like,
Mm-hmm.
"Hey, you need to make a standard for your fields or whatever." So we could do something like that, or
Yep.
No, yeah.
but yeah,
Or
um,
ESPN or something.
yeah, yeah,
That's
something.
interesting.
Or I think it could also say that it may be enough to say that there needs to be further research into it
Right.
and involve more fields to see if it really is. We just did two fields, but our data suggests that there may be an issue, and this is something that could be studied further. And I don't know, you know what I
No,
mean, to
totally. Totally.
go along those lines.
Hmm.
Sweet. Cool.
Okay.
All right. Sounds good, guys.
And then, do you know what has to be on the PowerPoint? Is it just a matter of taking all these kind of graphs and stuff and putting it out all together?
I think
I didn't
so.
look at the
I
PowerPoint
mean,
one.
right, neither have I.
Okay.
That's kind of what I was just picturing, just a real basic summary and then yeah, kind of using those graphs to have something to look at and kind
Hmm.
of just prove what we're saying kind of in a flow way.
Mm-hmm.
So yeah, I'll take a double look at that because I think I'm under that. So
And if you want any help, just to maybe, yeah,
For sure.
Obviously, the question, start out with the question and what our hypothesis is and whatnot. Okay.
Cool.
I'll look over both of them and see what else I can offer and help, and just let me know what you want me to do. Okay?
Sweet. Sounds
Thanks.
good. Thanks, guys.
Appreciate it. All right, I'll see you guys Thursday.
Sounds good. Bye.
Bye.
Bye.